In Interchapter B, we're going to discuss the nomenclature of alkenes, alkynes, and benzene. So remember, alkenes are going to be our carbon-carbon double bonds. And what we're going to see for our nomenclature is we're going to take that ane ending from the alkanes and we are going to change it to the ene ending for that double bond. For our alkynes, remember alkynes are the carbon-carbon triple bond. So for the alkynes, we're going to change the ending from ane to -ine. So notice we're changing the suffix, we're changing the functionality. So the ane becomes an -ine. We are going to see some examples where we will have both the alkene and the alkyne in the same compound. And we're going to change that ending from ane to an ene-ine. So you'll notice that we have both of those nomenclatures in there now. We have the ene and the -ine. The ene will come before the -ine, so we name it as an ene-ine. So to quickly just look at a couple of simple examples, here is our 3-carbon chain. So this would be propane from our alkane nomenclature. If we make this contain a double bond, this would now become propene. So the ending just becomes that ene. The prop is still there because it's our 3-carbon chain. If we make this a triple bond, so we have our 3-carbon chain here, this becomes propyne. So we're just going to be looking at changing those endings based on the type of double bonds or triple bonds that we see. So for our nomenclature steps, we still have to find that parent chain. So we still have to find the longest carbon chain. But this time that longest carbon chain has to contain the multiple bonds. So that is one of the new things, is we need to make sure that our longest chain contains whatever multiple bonds are found within the structure. We're still going to number our carbon chain, but we're going to number so the multiple bond gets the lowest number. So we're going to place the number for the multiple bond still before that suffix, but it has to have the lowest number. So if we look at an example with butene, so there's my 4-carbon chain with the ene, I now have to worry about the locant on where that double bond is. Because I can also have a 4-carbon chain with a double bond at the end of it as well, and these are very different structures. So we do have to include now a locant for where that multiple bond is. And where we put that locant, it's going to come right before the suffix. So the first one that I drew there with the double bond in the middle, this would be a but2-ene. The top one here would be a but1-ene. So we give it where it starts. Yes, the double bond goes through 2 carbon atoms, but we tell you the locant of where it starts, which would always be the lower number. So we can have a but2-ene or we can have a but1-ene, and the number is going to go right before the suffix, the ene or the -ine. This is a newer type of nomenclature. It used to be that it would go in front of the entire parent, but you really need to get into the new nomenclature. So please be very careful if you're using other sources that you may see some old nomenclature. The old nomenclature would label this as 2-butene, and it would put that locant in front of the whole entire parent, which gets confusing a little bit later on when things become more complex, so they have changed it. So please make sure that if you see this, recognize this as being an older nomenclature system, and you do not want to use that. You want to use the newer nomenclature system, which has the locant right in front of the suffix. If we have equal distance from either end to reach the lowest number for the multiple bond, you are going to then number so the substituents are the lowest. But again, that is only if it's equal distance from either end. The first priority is to put the multiple bond on the lowest number. If we are in a ring, the multiple bond is always between carbon atoms 1 and 2. So we typically do not number it because the multiple bond has to be in between carbon atoms 1 and 2. And we number then all the substituents appropriately. If more than one multiple bond is found within the structure, once again, we will use Greek prefixes to tell, and we will give multiple locants. So if we have 2 double bonds, it would be a diene. If we have 2 or 3 double bonds, it would be a triene. If we had 2 triple bonds, it'd be a diene. We would use that Greek prefixes to tell you how many, but then we would also need to include that many numbers as well, that many locants. If both double and triple bonds are found within our structure, the double bond takes priority over the triple bond to get the lower number. So if we had a structure that contained both a double bond and a triple bond, I would number this so that the double bond had the lower number. So I would name this as pent 1ene 4-ine. And please notice that we are using hyphens between numbers and letters. So we are using hyphens between numbers and letters. So this would be a pent 1ene 4-ine in terms of our numbering scheme. You're then going to take and you're going to write your name as one word, making sure you include all your substituents like we learned how to name back in Interchapter A. And again, it is all one word for us. We are also going to see this alkene as a substituent if it is just the CH2 unit coming off of the parent chain. So you do want to watch for that. We name it as a methylene substituent. So if I have this structure here, you see it's just a CH2 coming off, which would very much shorten my carbon chain, my parent chain, if I included it as part of the parent chain. Since it's at the end, it's a terminal CH2. We can name this as a substituent instead. So the way that I would actually name this structure would be 4-methylene heptane. So this allows me to kind of stick with the longest carbon chain if it is just a small CH2 unit coming off. It becomes the methylene substituent. We also have benzene. Benzene has our double bond. So remember we talked about benzene with resonance structures. The formula for benzene is C6H6. So our structure for benzene is going to be our 6 carbon chain with alternating single and double bonds. So we can draw our resonance structures for benzene, which just switches where those double bonds are found. So these would be my 2 resonance structures. I could then, if I did not want to write both resonance structures, remember you will see this drawn with a circle in the middle to tell you we have those alternating single and double bonds. But in all reality, all of those bond lengths are the same. So with this is what we refer to as our aromatic compound. This was our arene ring. So when we get ready to name benzene and these benzene derivatives, so benzene that has substituents associated with it, first we're going to find the parent, which will typically be that benzene ring that we would be looking for. If we have 2 or more branches, we're going to number them so the substituents have the lowest numbers. Once again, if 2 numbers can be the same, if it doesn't matter which direction we go, to the left or to the right, we use the alphabet to prioritize. So the first one that comes in the alphabet would be the one to get the lowest number. We are then going to name all of it as one word. So nothing really changes with our nomenclature when it comes to benzene. We would name it as we would any other cyclic compound. What changes is the parent becomes benzene. We are going to see some di-substituted benzenes that have some different locants that we can use with them. The key here is being di-substituted, di meaning 2, so we are only allowed to have 2 substituents on benzene to use these very specific prefixes. So I have benzene drawn and I've got 1 substituent already on benzene. So where I place the second one is what is going to dictate the prefix that we would use. So my ortho prefix, this would be considered my ortho location. So the ortho location on a di-substituted benzene really has a 1-2 relationship between the 2 substituents. And it does not matter which side. What just matters is that 1-2 relationship. For the meta, with meta, they're going to be in these positions. So meta really has that 1-3 relationship that we would be looking at. Again, it does not matter which side you go to the right or to the left. What matters is that 1-3 relationship. We then also have a para position. The para position, there is only one para position, and this is the 1-4 relationship in a disubstituted benzene. So when you are naming, you can either use a 1-2, 1-3, or 1-4, or you can use the prefix of ortho, meta, and para. You would not use both of them. You would use one or the other. We do also see some common names pop up with benzene that you will want to be familiar with. So I have the common name listed first, and then I have more of the IUPAC-ish name listed in parentheses. So first we have toluene. Toluene is our benzene ring that has one methyl substituent coming off of it. So that's why it's referred to as methylbenzene, but it is commonly referred to as toluene. We then have cumene, which is isopropyl benzene. So we have our benzene ring, and then we would have that isopropyl unit coming off of it. Anisole, which is our methoxybenzene. So we have our benzene ring, and then coming off of that benzene ring is our OCH3 unit. We can also have styrene, which is also vinyl benzene. The vinyl unit is going to be a CH2 unit coming off of it, so it would be this double bond unit. These common names can pop up in naming larger groups if that branch is in position number 1. So we can have a chlorotoluene or 2-chlorotoluene, and we can name it as the common name of toluene if we have both a methyl and a chlorine on it at the same time. But the key is that the branch that makes it toluene needs to be in position number 1. So you will see some of this common name pop up again as we start looking at larger groups with benzene. We can also have benzene as a substituent. So benzene does not have to be the parent, depending on what else is coming off of the benzene ring. So if the benzene ring has a chain that is a very large chain, or that chain has other functionality on it, halogens or some of the other functional groups that we'll be talking about or that we have looked at already, the benzene becomes a substituent. It is too small to name as the parent. So if we just have the benzene ring directly coming off of the parent chain, this is referred to as a phenyl group. It's a phenyl substituent. If we wanted to use an abbreviation, you would see this abbreviated as a PH coming off of a very large parent chain or a parent chain with other functionality. This would be a phenyl group. We will also talk about a benzyl group. With our benzyl group, there is a CH2 unit carbon between the parent and the benzene ring. This is a benzyl substituent. So this is a benzyl substituent. You will see this abbreviated BN potentially as you're going through very large structures. So this is when the parent chain has other functionality. It's very large in comparison to the benzene ring. So we would name that benzene ring as a substituent. So the phenyl group or the benzyl group. So again, let's look at some examples. Again, I would recommend pausing the screens, trying to work through these 4 examples, so 2 names, 2 drawing of structures, before you go and actually look at the answers. So our first one here, this would be named as 5-chlorohextuene. So remember, the multiple bond takes precedence to get the lower number compared to the substituent. So this would be 5-chlorohextuene. Our second one would be 2,5-dimethyl octa 3,5-diene. So you'll notice with this one, we are again still separating numbers with commas, hyphens between letters and numbers. But what I do want to point out is we have added in this extra A. This is octadiene. This really comes back from the old nomenclature where you would not put two consonants beside each other. So it would not be octadiene, it would be an octadiene. That has still stayed with the newer nomenclature. So this would be an octa 3,5-diene. Our structure for 1,2-difluorocyclohexene, we have a 6-membered ring, so there's our cyclohex. It is an ene, so we have to have a double bond. Remember, since it's a ring, that double bond needs to come between carbon atoms 1 and 2, which is why there is no number there. We then have a fluoro group on carbon atom 1 and a fluoro group on carbon atom 2. We have already defined the carbon atom 1 and 2 because of the double bond. So this would be our structure for 1,2-difluorocyclohexene. Then we have our structure for 2-chloro-4-ethylhex-2-ene. Once again, we have a 6-membered carbon, but this time it is a straight chain carbon. On the second carbon atom, we have a double bond. From there, we have on the second carbon, we have a chloro group as well. And then on our fourth carbon atom, we have an ethyl group, which is a 2-carbon chain. So your structure should look something similar to this. Again, it doesn't matter what side you start on. If you started numbering on the right instead of the left, it does not matter which side you start numbering on. What matters is the number count compared to the chain itself. Again, with our last 5 examples, I recommend pausing the screen and trying these on your own before you see the answers. So for our first structure, we would name this as 4,4-dibromo. Pentuine. So 4,4-dibromo pentuine. Remembering once again the multiple bond takes precedence over the substituents. The second one would be 3-methyl hept-2-ene. Four-ine. So 3-methyl hept-2-ene 4-ine. Since we have both the double and the triple bond. Our last structure here would be butylbenzene. So our last structure would be butylbenzene. To draw meta-bromochlorobenzene, first I have to draw my benzene ring. That becomes my parent. And then I have a chloro and a bromo group, and they need to be in the meta position. So remember, that is our 1,3 position. So I would put a bromine and a chlorine, and again, they would have that 1,3 relationship with them. The last one, 1,2,4-trimethylbenzene. We would have our benzene ring. And then we would have in positions 1, 2, and 4 methyl groups. And again, it does not matter where you start with carbon atom number 1.